just starting the reading. The replacement of hydrogen atoms in a hydrocarbon aliphatic or aromatic by halogen atoms result in the formation of alkyl halide haloalkanes and aryl halide haloarenes respectively. Now see, we know that there are the hydrocarbons. Okay, hydrocarbons are the compounds of carbon and hydrogen only. Okay, carbon and hydrogen only. Organic chemistry basis is the carbon and hydrogen is present as default. Okay, so the compounds made up of hydrogen and carbon, they are the hydrocarbons. Saturated hydrocarbons are the ones which contain the single bond only. And children, remember here that when I am talking about the single or saturation or the presence of single bond is between the carbon atom, not between the carbon and any other element. If I am saying the unsaturated, that means we are talking about the multiple bonds, that is the double or triple bond between carbon atoms, not between carbon and any other element. Now this is the meaning of saturation and unsaturation. It still remains the doubt with the student, and these small things make the chemistry tough. So coming back, alkanes are the simplest hydrocarbons, and all other compounds are considered to be the derivatives of hydrocarbon. Says the simplest example, the simplest hydrocarbon or simplest alkane is the methane. This is the structure of methane. Its formula is CH4. When one of the hydrogen is replaced by any other atom or group of atoms, that is the functional group, it becomes the derivative of the alkane, right? So as we are dealing with the haloalkanes, that means the hydrogen of the alkane is replaced by one of the halogen atom. Okay, one of the halogen atom, which makes it haloalkanes. Haloalkane is the IUPAC term and alkyl halide is the common term. Alkyl halide is the common term. Now coming back to the haloarenes. Okay, like we have the hydrocarbons in aliphatic chemistry, we have the hydrocarbons in the aromatic chemistry, and one of the simplest hydrocarbon of the aromatic group is benzene. Benzene having the molecular formula C6H6. Okay, and if I write its structure C, fifth and sixth carbon atom, and there is alternate single and double bond, and each of the hydrogen carbon is having one hydrogen. As you know, the valency 4 should be filled for the carbon atom, which is using the hydrogen until unless any specific element is mentioned over there. I hope it is clear. Now the next sentence says haloalkanes contain halogen atoms attached to sp3 hybridized carbon atoms of an alkyl group, whereas haloarenes contain halogen atom attached to sp2 hybridized carbon atom of an aryl group. One thing, alkane minus one hydrogen atom is alkyl, arene minus one hydrogen atom is aryl. Okay, so here in the alkyl halide or here in the methane, the structure which is drawn over there, okay, in this it is sigma bond, it is sigma bond, it is sigma bond, it is sigma bond, that is 4 bonds it is containing are the sigma bond. Carbon atom containing 4 sigma bond or associated to the other atoms through the 4 sigma bond is sp3 hybridized carbon, is sp3 hybridized carbon. Okay, so here this carbon atom is sp3 hybridized carbon, this carbon is sp3 hybridized carbon atom. So this carbon atom is sp3 hybridized, 4 sigma bonds means the sp3 hybridization. Okay, now so here this is sp3 hybridized carbon atom to which is attached the halogen atom. So alkyl group is containing sp3 hybridized carbon atom. Now coming back to the benzene structure of benzene. In benzene we are having the carbon atom attached through the 4 bonds. Of course, the valency of carbon is 4, so there must be the 4 bond. And what I told you, that every single bond is the sigma bond. So sigma, 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 another sigma, another sigma, and another sigma. Single bond is always the sigma bond. And where we have the double bond, one bond is sigma and other bond is pi. One bond is sigma and other bond is pi bond. So it is 1 sigma 1 pi, 1 sigma 1 pi, 1 sigma 1 pi. So if we see here the carbon atom here is this one. It is having 1 2 3 sigma bond. This carbon atom again 1 2 3 sigma bond. Here 1 2 3 sigma bond. Now from how I am counting the 3 sigma bond? One sigma bond with the hydrogen atom, another sigma bond with the carbon bond, another sigma bond, the third sigma bond is with the carbon atom to which it is doubly bonded. One is sigma and one is pi bond. So all the 6 carbon atoms are having 3 sigma and 1 pi bond. It makes it sp2 hybridized. What does it make to? It makes it to sp2 hybridized. Okay. Okay. So each of the carbon atom is sp2 hybridized carbon atom, right? When we are having the 4 sigma bond, it is sp3. When it is having the 3 sigma bond, it is sp2. So if one of the hydrogen is displaced here, and here attaches the halogen, it becomes aryl halide. It becomes aryl halide. Okay, it becomes aryl halide. Aryl halide is the journal term for haloarenes. Haloarenes is the IUPAC term, as haloalkane is the IUPAC term and haloarenes is the IUPAC term. But if we use alkyl halide is the common term, and the same way aryl halide is also the common term, right? Aryl halide is the common term, aryl halide. Okay. Now we come back to this. We continue reading. Many halogens containing organic compounds occur in nature, and some of these are clinically useful. These classes of compounds find wide application in industry as well as in day-to-day life. They are used as solvents for relatively non-polar compounds and as starting materials for the synthesis of wide range of organic compounds. Mentioned here is they are used as the solvent, like carbon tetrachloride. It is the industrial solvent. Okay, one of the example of industrial solvent. Chloroform is there, that is the industrial solvent. And in chemical bonding, you have studied that covalent compounds are non-polar in nature and like dissolves like. So non-polar compounds are used as the solvent for the non-polar solutes. Okay. Chlorine containing antibiotic chloramphenicol produced by soil microorganism is very effective for the treatment of typhoid fever. Now this line you should understand, especially those children who are preparing for the competitive exams. Okay. Then again, our body produces iodine containing hormone thyroxine, the deficiency of which causes the disease called goiter. Again, highlight it or underline it. Synthetic halogen compounds with chloroquine is used for the treatment of malaria. Again, another question which you may get. Haloethane is used as an anesthetic during surgery. Certain fully fluorinated compounds are being considered as potential blood substitutes in surgery. All these 3-4 examples are given. You should underline, you should keep in mind if you are preparing for the competitive exam. In this unit, you will study the important methods of preparation, physical and chemical properties, and use of organohalogen compound. So children, this introduction we have understood clearly. It is one time read, and whatever you have highlighted, make sure that it is very clear. As soon as you open the chapter, you have not to start with the first line, and you can directly come to those important points which you have highlighted. Now we come to the other part of the chapter, that is the classification. How we can classify the haloalkanes or haloalkenes. There are different criteria for their classification. Okay, there are different criteria for the classification. So this section is for the classification. Now, one classification is on the basis of how many halogen atoms are attached. How many halogen atoms are attached to the alkane, or how many hydrogens are replaced by the halogen. So on that basis, it is simple. It can be monohalogen derivative. It can be monohalogen derivative if it is 1. It can be dihalogen derivative if it is 2, and so on. And so on. Right? So, like in your book is given monohalo, dihalo, trihalo. For the examples of the aliphatic, ones, we can keep the examples as C2H5, say Cl. C2H5 comes from the ethane. One hydrogen is replaced and chlorine is placed. CH3Cl, it is monohalogen. If I replace one more, it is C2H4 and Cl2 dichloro. CH2Cl2 dichloro. CHCl3, which is commonly known as chloroform, it is trichloro derivative, right? It is chloroform, common name. If I write CCl4, all the 4 hydrogens of methane are replaced, and it is carbon tetrachloride. It is carbon tetrachloride. Okay, it is carbon tetrachloride. Now, likewise, if we are seeing for the if we are seeing for the haloarenes, then benzene ring remains as such. Okay, and we put just one chlorine or halogen on the benzene ring. It becomes haloarene or monohalogen derivative. Likewise, if I am putting the 2, then it is X, and X dihalogen derivative. If the 3, it will be trihalogen derivative, trihaloarene. Okay, remember the classification is on the basis of what? On the basis of the number of hydrogen atoms getting replaced by the halogen. Yeah, it is one criteria of classification. What is the other criteria of classification? The other criteria of classification is whether the halogen is attached to sp2 hybridized carbon atom or sp3 hybridized carbon atom. Okay, what is the criteria? Whether the halogen is attached to sp2 hybridized carbon atom or sp3 hybridized carbon atom. Now, see, methane, it is HC, H, H and X. It is sigma, sigma, sigma and sigma. So it is sp3 This is alkyl group, alkyl in particular methyl group. The journal formula of alkane is CnH2n plus 2. If we remove one hydrogen and it becomes CnH2n plus 1, one valency of carbon is free. There comes and attaches the halogen. So here halogen is attached to sp3 hybridized carbon atom. Okay. We can have another example. Say one of the hydrogen I replace with another alkyl group. Okay. Here carbon, hydrogen, hydrogen. Instead of this hydrogen, I write here CH3. And again I put halogen here. So this is sigma bond, this is sigma bond, this is sigma bond, this is sigma bond. Still the carbon is sp3 hybridized. Now I make one more change. Okay, this hydrogen is as such, this methyl group is as such, but this hydrogen, instead of hydrogen I put here another methyl group, and halogen is still attached to this carbon atom. Okay, so sigma bond, sigma bond, sigma bond, sigma bond, again 4 sigma bond. So carbon is still sp3 hybridized. I can make one more change. Okay, carbon here X, here CH3, here CH3, and this hydrogen also I replace with CH3. So sigma bond, sigma bond, sigma bond, and sigma bond, and 4 sigma bond. That means still this carbon to which the halogen is attached, it is sp3 hybridized. So all these examples which I have written, methyl chloride and ethyl chloride, and this is one propyl chloride, this is your butyl chloride, all these are common names, children. Okay, so in all these 4 examples, the halogen atom is attached to sp3 hybridized carbon atom. But yet there is the difference. What is the difference? This is primary alkyl halide, 1 degree, or primary alkyl halide. This is also 1 degree or primary alkyl halide. Okay, and this is 2 degree or secondary halide, and the same way it is 3 degree or tertiary alkyl halide. It is tertiary alkyl halide. And I hope all of you know what is primary, secondary and tertiary carbon atom, as it is the part of the basics of organic chemistry. When the carbon atom is attached to no carbon atom, or to one carbon atom only. See, this carbon atom is attached to one carbon atom only. Okay, so no other carbon atom or to only one carbon atom, it is primary. When the carbon atom is attached to 2 other carbon atoms, then it is secondary. And when the carbon atom is attached to 3 other carbon atoms, it is tertiary. Okay, so all of them are having the halogen attached to sp3 hybridized carbon atom, but the first 2 are this, and this is primary alkyl halide, this one is secondary alkyl halide, and this one is tertiary alkyl halide. So these are 2 different aspects. Okay, these are 2 different aspects. Okay, now we come to another example. Okay, there is one very common term. That is allylic and vinylic, where children get confused. Allylic and vinylic. First we go to allylic. What is allylic halide? See, allylic group is what? The first member of alkene is CH2 double bond CH2, and the that is ethene. It is ethene. The second one is propene, meth eth prop, propene, and we know there is no alkene with the one carbon atom. Be careful, the first member of alkene is with the two carbon atom. This you must have studied when you have done the hydrocarbons. The second alkene is the propene, that is CH3CH double bond CH2. Now what do we do if we take out one hydrogen atom from this? CH2, I write in way to make you understand better, hydrogen, 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 and hydrogen, and CH double bond CH2. If I remove one hydrogen, from this structure, if I remove one hydrogen from here, it becomes CH2 double bond CH, CH2 with one valency of carbon as the free. It becomes CH2, and this is allylic group. This is allylic group. Remember children, allylic group. So how can we simply remember this? Propene with one hydrogen less from the carbon atom which is attached to doubly bonded carbon atom is the allylic group. And if the halogen is attached, to this carbon atom, it becomes allylic halide. What is allylic group? Allylic group is this group. This group is the allylic group. CH2 double bond CH single bond CH2. This is allylic group, and when the halogen is attached to the allylic carbon, it becomes the allylic halide. This is allylic group. I hope it is clear. Now, one thing again we check. Is it sp3 hybridized carbon atom? Is it sp3 hybridized carbon atom? We draw the structure. Carbon, one hydrogen, another hydrogen, carbon, hydrogen, double bond, carbon, hydrogen. But which carbon atom we have to check? We have to check the carbon atom to which halogen is attached. We have to check that carbon atom. We have to attach that carbon atom. Now single sigma, 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 and sigma. So 4 sigma bonds means sp3 hybridized carbon atom. So this is allylic halide in which the halogen is attached to sp3 hybridized carbon atom. Is that clear? Now what another example we can take? It may be the cycloalkane also. It may be on the cyclic structure also. For example, say this one. Children, each corner indicates carbon. Say it is double bond. So this is carbon, 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 this is carbon. And as the 4 valences of carbon should be satisfied and nothing is mentioned, that means remaining will be hydrogens. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3 and 4. 1, 2, 3 and 4. So which are the allylic? Allylic carbon atom is the carbon atom. It is the carbon atom attached to. It is the carbon atom attached to doubly bonded carbon atom. So these are doubly bonded carbon atom. Either this is allylic carbon atom or this is allylic carbon atom. Okay. This is allylic carbon atom or this is allylic carbon atom. And if the halogen is attached here, if the halogen is attached to allylic carbon atom, then it is the if it is attached to the allylic carbon atom, this is allylic halogen. Remember, allylic carbon is the carbon atom just next to the doubly bonded carbon atom. Allylic carbon atom is the carbon atom which is attached to the doubly bonded carbon atom. Yeah. Another is the benzylic halide. As we have allylic group, the same way we have the benzylic group. But as the term indicates, it has something to do with the benzene ring. Okay. It has something to do with the benzene ring. I draw benzene ring here. I draw benzene ring here. Alternate single and double bond. Now, if one carbon is attached to here, so this is doubly bonded carbon atom, this is doubly bonded carbon atom. So carbon atom next to the doubly bonded carbon atom. Carbon atom next to the doubly bonded carbon atom is the allylic carbon atom. So if, right, but if we are talking about benzene ring, we are considering benzene ring, it won't be allylic, it will be benzylic. So this is benzylic carbon atom. And when the halogen is attached to this carbon atom, halogen is attached to this carbon atom, it is benzylic halide. It is benzylic halide. It is benzylic halide. Okay. Spelling has gone wrong. Sorry. Benzylic. It is benzylic halide. See children, allylic halide, alkyl halide, benzylic halide. sp3 hybridization is one concept. Primary, secondary, tertiary is another concept. Okay. See, if it is hydrogen, so carbon atom attached to one other carbon atom is primary, or not attached to any carbon atom is primary. If it is attached to two carbon atoms secondary, attached to three carbon atom is tertiary. So it can be primary, secondary or tertiary with the sp3 hybridization. Clear? Understood? Okay. Then we move to the next part. Okay. So another class. Here we have talked about the compounds. Here we have talked about the compounds which are in which the halogens are attached to sp3 carbon atom. Now we are going to the next categorization in which the halogen is attached, to sp2 hybridized carbon atom. Now sp2 hybridized carbon atom means carbon atom is containing one double bond, or it contains 3 sigma bond and 1 pi bond, and about sigma and pi bond you must have studied in detail in your grade 11th. Okay, or you can refer my lectures based on the topic. Okay, now here we come across the term vinylic halide. Now what is vinylic halide? Okay, again I go back to alkenes. The first member of alkene is CH2 double bond CH2. CH2 double bond CH2. So C double bond CH2 hydrogen and hydrogen. Now I remove one hydrogen. Okay, it becomes vinylic group. It becomes vinylic group. One valency gets free. Okay, it becomes vinylic group. Okay. So when halogen comes and attaches here, it becomes vinylic halide. So what is the difference here? The halogen is attached to the doubly bonded carbon atom, whereas in the previous one, allylic one, it was attached to the carbon atom which is next to the doubly bonded carbon atom. It is attached to the carbon atom which is next to the doubly bonded carbon atom. Clear? Okay, so remember how you have to remember and how you have to make the difference. Okay, now in this case here, let's see what is the hybridization. It is sigma, it is pi. It is this hydrogen is attached to the sigma bond. So 2 sigma 1 pi. Let me draw it again. Okay, carbon, double bond, carbon, hydrogen, and here we have the halogen. Sigma, and pi. 3 sigma, that means sp2 hybridize. So vinylic halides are the example. Okay, so vinylic halides are the example of the sp2 hybridized carbon ones. Okay, where the halogen is attached to sp2 hybridized carbon atom. Okay, we take another example again with the ring structure, right? This one, as we take for the allylic one, but abhi kya hai? Hydrogen is attached here, halogen is attached here. Okay, where? To the doubly bonded carbon atom. This carbon atom is doubly bonded. Right? And if we check the hybridization, this is sigma, and out of these two, one is sigma, one is pi. So it is sp2. And why it is example of vinylic? Because the halogen is attached to the sp2 hybridized carbon atom, doubly bonded carbon atom. Okay, now then we come to aryl halide. See children, the example which we have taken for the vinylic, okay, the example which I have taken for the vinylic, or which definitely from your book it is, okay, but it must be clear. See, this ring is not aromatic. Okay, you must be knowing the closed chain structure. The ring structures may be aliphatic, may be aromatic, but the aromatics, they fulfill certain characteristics which make them aromatic. Okay, now under the category of sp2 hybridized, aryl halides also come. Okay, Okay, so this is benzene ring, double bond, single bond, double bond, single bond, this. And here we are having one halogen. Okay, so single bond, and where it is double bond, one is sigma and one is pi. So it is sp2 as it is on the benzene ring. So it is aryl halide. So this way the aryl halides are also the halogen derivatives of arenes, in which the halogen is attached to sp2 hybridized carbon atom. Clear? Okay, so with this we are done with the classification of the halogen derivatives, be it alkyl halides or be it aryl halides. I hope the concepts are clear. The small points which we come across, the terms which are mentioned, they should be clear. These are the bases, and if they are clear, as you move ahead with the other chapters, the things will be much more easier to you. Hope you like it. Thank you very much. Have a nice day.